Are you confused about how to securely store access tokens in your application? You're not alone. Today, we're diving into the world of OAuth 2 and the authorization code flow, specifically focusing on how to handle access tokens safely. I totally get it. The idea of handling sensitive information like access tokens can be daunting. Many developers worry about exposing these tokens to the client side, and rightly so. It's a common concern in the tech community. Let's look at a specific question from a user. They asked, how should the page server store the access token once it is obtained? They referenced a code example that checks for an existing token in a cookie. Sound familiar? If you're wondering the same thing, stick around as we explore this together. So what's the issue here? Storing access tokens in cookies can seem convenient, but it raises security concerns. If the cookie is transmitted to the client browser, it could potentially expose the token. Let's break this down further. And don't go anywhere. By the end of this video, you'll know the best practices for storing access tokens securely, and I promise you won't want to miss it. To securely store the access token, the user should consider using server-side storage instead of cookies. This approach minimizes exposure to the client side. One option is to use a secure database to store the access token. The user can encrypt the token before saving it to ensure that even if the database is compromised, the token remains protected. Another approach is to use in-memory storage, which keeps the access token in the server's memory. This method is fast but requires careful management to ensure tokens are refreshed and not lost. If the user still prefers to use cookies, they should ensure that the cookie is marked as HTTP only and secure. This prevents client-side scripts from accessing the token and ensures it is only sent over HTTPS. Finally, the user should implement a strategy for token expiration and renewal. This ensures that the application can handle expired tokens gracefully and request new ones as needed. Fun fact, the first web cookies were invented in 1994, and they were originally designed to help websites remember user preferences. Now they hold much more sensitive information, so security is key. Now let's look at the answers provided by other users. This user clarifies that the cookie storing the access token is never exposed to the browser. Instead, it is part of the server's response to the authorization server. The callback controller extracts the cookie from this response, ensuring the token remains secure. They also mentioned that while the authorization server could store the token in the request body, it wouldn't change the visibility of the response to the client. Additionally, they note that the use of state in the callback controller is non-standard and should ideally be validated to prevent CSRF attacks. Let's check out another perspective from a different user. An alternative approach suggests using the implicit grant flow if you're requesting a resource directly from the browser. For server-side access, it's recommended to store the authorization code and generate a new access token each time it's needed. Remember, access tokens typically have a short lifespan, often around 5 minutes, so there's no need to store them. Here's a pro tip. Always review your token storage strategy regularly. Security best practices evolve, and staying updated can save you from potential vulnerabilities. And there you have it. You now know how to store access tokens securely. Remember, security is an ongoing process. If you found this video helpful, please subscribe for more insights and keep your applications safe.